Good afternoon, colleagues. Mikhail, thank you very much for a great presentation and absolutely magnificent project, Deep Pavlov. I My name is Dmitry Chernous. I'm from ABBYY, and I will talk about our approaches to NLP, and I will speak about how linguistics can become one of a very helpful component and approach towards tackling very complicated tasks where machine learning is not always enough because of lack of samples, for instance. So there are a lot of approaches towards how to analyze the texts, and now with transformers around and all other things, cool things around, there is understanding here and see me. So the understanding is that we go away from approaches related to rules. This is a very good area to develop in, and I will talk more about this approach today. The approach is based on rules, but we will talk about how rules can be smart and interesting. So rules based on not just cases, but on systems and generalization. And universal language based model will help me in this. So universal language modeling is the title of my presentation, and hybrid models that combine language model and rules. We'll also talk about this, and we'll touch upon machine learning, of course. And actually, in fact, this is a very beautiful idea in our today's conversation. But before I go to describing it, the implementation of this idea gave a lot to the client, like Sberbank. We implemented this approach for several projects. Two of them I will show as cases today. First of all, project for monitoring of media and extracting risk indicators from the news media. Risk indicators that are articulated in news in the format of developments articulated. And these developments can be various journalists, even if the same development is described with different words and in different formats and is also mentioned in various places in the text of the news in order to extract such risk information and define that several publications that are completely different from one from the other, and they have the same risk factor. So for such tasks, it is useful to use linguistics and generalization on the level of rules. So there are samples to launch. There are not enough samples to educate machines to extract that. So now we have 92% of accuracy and 88% in comprehensiveness. And another rule-based case, loans for legal entities. So this project works with text of documents of contracts and articles, various articles. And so now we have accuracy of 95% of extracting the needed data from such text data set. Based on generalization and rules, linguistic modeling is the basis for such approach. Why modeling is important today? Well, actually, this is a very interesting thing. Language is an artificial thing that is a system, a structure by definition. And in this sense, to just decompose a sentence and think of various semantic classes depending on the context of each word is a simpler task to tackle, because cat and dog both has 2 ears, 2 eyes, 4 legs. There are lots of various species that are different from one another, and those that very similar one against the other. So to differentiate one from the other, you need samples, and generalization is coming from the empirical data. But here is a different approach from the outside, from the inside of the structure of the language, since language is a structure, as I already said. So let's introduce a couple of terms I will use further on that are in the there are the. So let's take a couple of terms that are related to linguistics we will use when discussing the rules. So the deep position is called like this because this is a deep level of generalization that allows us to articulate various ideas in different ways and interpret them for us as human beings and for a machine. Distracted by the chat, it seems like some technical delays are there. So this is so here we are talking about the fact that the same idea can be articulated in various ways. What we already discussed. Well, it's okay. So the boy is building a house. The house is built by a boy. The idea is the same. The boy is playing games. The idea is the same, but the expression is different. The same meaning, but with different words. And if we use the linguistics approach, this helps us to interpret these words in the same way, using the semantic syntax parcels and applying it to these conversations, we can create a structure which is the same for both. And this is input data, for any algorithms based on machine learning or rules based, since linguistics can be used for any neural network. And let's talk about the following next. Yes, there are ties between words, semantic roles, and there are semantic classes that describe the role of a word. If you use such approach, you have an opportunity to work with semantic tree that can actually show all objects of the real world. This is the approach we use in our company. In this semantic tree, going from general things to specific things, all domains are defined with various words, and all of these words can have interpretation in its language. And the thing is that since the structure of the meanings is the same for various languages, this hierarchy is the same, just the expression of this word in this language is different. And how the ties are structured, so let's have a look at two examples here. Two cases, but there are four of them actually. Two cases for two languages, for Russian and English. Jack has built the house was built by Jack. And if we look at how semantic and syntax parcel the breakdown is made, we see that the structure is the same. In English, it's a bit more complicated because there are articles and the verb to be. We do not have it in the Russian language, but there is the agent in both. This is the Jack's semantic role, and there is the object home. This is its house. This means that the ties between the words are the same, their semantic class is the same, their meaning and role in the sentence is the same. The same thing with English. And using universal semantic hierarchy and using universal syntax representation, we can translate from one language to another. And what might help us in machine learning in terms of all these approaches? The approaches we use in our company and other semantic parcels do exist that explain words in sentences and how they are related. All these things can be used as features for machine learning. So it can be the frequency of classes or compatibility of various tree links where we create a tree and understand what length, how lengthy this connection is between the words standing in various semantic roles of various semantic classes. So the parser works like this. Parser as the main technology inside our NLP technology allows us to structure this expression for every sentence and look at all the features, and then these features will go to machine learning in order to train machines various things. Another nice point is in the following: through such approach, there is an opportunity to cut the number of samples that we need as input data that should be marked, because there is generalization since the general structure is defined. And this is a task for everyone, for machine learning, to learn how to process data in order to not to mark tens of thousands of samples. Well, no one is marking such amounts of samples. Yes, there are algorithms now, but using the parser as source of features for ML, we can speak about starting machine learning from 20 to 50 samples if it is a very good heterogeneous, homogeneous set of data. So let's go to real examples, cases, how the rules can be drawn based on the theory. And before that, a small comment. We have two sentences. John asked Mary to leave the room, and John promised Mary to leave the room. So it's absolutely two different sentences. One word is different. In Russian and English, it looks the same. But if we look at the slide now, we can understand that in this case, in first case, in one case, John is leaving the room. The other case is Mary leaving the room. And those that understand linguistics can tackle this task and structure the whole thing in a proper way in terms of roles and semantics. And we can use it in further on in machine learning. Another thing which is good about rules, how we can use them and what is the basis of it. The rules, through rules, we tackle specific cases and save the models. But if you have samples or a large amount of variations within the framework of the task you tackle, of course, this approach together with linguistics can really help. You can just set one rule and it can cover everything. We are talking about predictor. Just look at the structure of the words. It is done in a very complicated way in order to confuse the machine. And then some other words coming further on. And what is interesting about it, the rules you see at the upper part of the screenshot is as follows. So for active verbs in object correlation, please find the person who is managing and assign the value of POS identifier. So it means that we find a situation that the Director General was appointed, but since seeing the situation, we can also identify it by the type of class and type of connection of the object, and we can take the identifier. You see the graph analysis, and you see how the part of semantic hierarchy looks like, and how it is related to the word, the director, how it looks like with the word elect, appoint, and director. And the same thing happens with president. A completely different graph analysis, but the same semantic class still, and the same connection type object. And we keep the same semantic class. Again, semantic class that is shown in the rule is generalization, is the pre-word, and the director general and the other persons mentioned is the year that is managing, and to elect, to appoint, and these are the afterwards for the activity verb. So with all these rules, we cover the all three stories, and we can do the same with other languages. One rule can cover several samples. So this situation looks quite similar when we have 10 articles about the same topic, but the words are different. But we need to identify the risk indicator, not only the indicator, but also the people and organizations that are related related to it. If you just classify, yes, we can go with this task through classification. You can process several articles on conflict of shareholders, for instance, through your algorithm. It analyzes articles, and you monitor your articles to avoid a conflict of shareholders with your bank. And if we try and find counterparty banks through keywords, you can have a lot of false positives. If you use a rule that is generalizing in this way, it'll find proper wordings in news that is related to this risk factor, and through types of connections through various relations to various semantic classes, we can find the actors of this factor, not just the conflict of shareholders that happened in one bank, and at the end of the article all banks are listed, those that went through various situations and problems this year. So if you use keywords and classification, you will have this news in your sample. But if you use search for the indicator you need, and you care about having this indicator related to your counterparty, you will not find this news because this article is about another organization, and so on. So I showed very simple rules to you. For instance, productive rule, factors of external and internal environment. A very simple rule that covers a lot of situations that can happen to counterparties. And the same thing with the fact of changing ownership. The rule is a bit more complicated, but the principle is the same. We mostly look at the semantic class, semantic roles, and types of connection. And this allows us to have a very good, beautiful sentence to break down into such graph analysis. And using this rule, have the result like this. When part of the text is finding the wording and the risk factor and all organizations related to the case. And so that's how we achieve the synergy of linguistics approach and approaches based on rules and all features that create linguistic parser and the semantics and all classes and types of connections can be used as features for machine learning through thus cutting the number of samples to have good results. In my practice, in 21 samples, we had results of 92% of accuracy in good vast data set. Thank you very much for your attention. I do not know whether colleagues were able to overcome technical difficulties. Despite everything, I hope you heard my presentation and it was interesting for you. Thank you.
Теперь я вижу Дмитрия.
Now we can see Dmitry. Dmitry, can you hear me? Yes, I also can hear you for the first time. Thank you very much. Good afternoon.
Я поздоровался.
Прекрасно. Тогда я могу задать свой вопрос.
Okay, I can ask my question. Little time left. RBC is doing a contest now, and the results of this competition can be quite valid for ABBYY. Are you going to do something with them? Are you following? Well, it is similar to our. To what we are doing, to identifying typical mistakes. Technologies are very similar. Well, to be quite candid, I am not very much aware about this competition. And if it's a good and interesting competition, and I'm sure some teams from our company are involved, indeed, as you described them, is quite similar to what we are doing. It's replacing all difficult substances from the text, not always newer, and opportunities to somehow describe at the generalized level the situation that can be very different, especially if it is reading and literary texts provided. Thank you very much for your answer. Thank you.